In this video, we'll be solving multi-step linear equations. To solve this equation, the first thing we want to do is distribute the numbers that are in front of the parentheses. We want to multiply the 4 times everything inside the parentheses and the 2 times everything inside. So that will give us 5 plus 4x, and then the 4 times the minus 2 is minus 8, equals, then multiplying out the 2 times x is 2x, and 2 times 7 is plus 14, and then we still have the plus 1 at the end. Now look at the left side of the equation and see that we could combine the 5 and the negative 8. 5 minus 8 is negative 3. We still have the plus 4x equals, look on the right side, I can combine the 14 plus 1. So 2x plus 15. Now, there's nothing else I can do on the left side. There's nothing else I can do on the right side. So I want to get my x's together. To bring my 2x over to join with the 4x, since it's a positive 2x, I have to do the opposite, which is negative 2x. That gives us negative 3 plus 2x equals 15. I'm trying to get my x by itself. We always get rid of numbers that are added or subtracted before we get rid of numbers that are multiplied. So I want to get rid of the minus 3, I do plus 3. And whatever I do to one side, I have to do to the other. Now we have 2x equals 18. The 2 and the x are right beside each other, which means multiply. So to undo it, we divide. And x equals 9. The next equation has a multitude of fractions in it, and we can get rid of fractions in equations by multiplying everything by the common denominator. If I have 7, 6, and 3, the common denominator for those three numbers is 42. So I'm going to multiply every single fraction on the top by 42. That includes the 5 at the end. It's also technically a fraction if you put it over 1. So every term gets multiplied by the common denominator, even if that number is not a fraction. So what this does is it allows the denominators to divide into the 42 so that I won't have any fractions. When I divide 7 into 42, that leaves me with 6. When I divide 6 into 42, I have 7. On the other side, 3 into 42 is 14. And then 1 into 42 at the end just leaves 42. Now, what I'm left with after the dividing needs to multiply by everything in the numerators, everything on top. So the 6 with the first fraction multiplies by both the z and the 4, giving us 6z plus 24. Then the 7 times z is just 7z equals, and then we'll take the 14 times both the z and the 8. That is 14z plus 112. And then at the end, 42 times 5 is 210. So multiply every fraction by the, actually every term by the common denominator. The denominators cancel in to the 42 every time, and what you're left with multiplies by the top. If it's a whole number like the 5 on the end, you just multiply the 42 and the 5, and that's where the 210 came from. Now on the left side, I can combine 6z and 7z and end up with 13z plus 24 equals. On the right side, I can combine the 112 and the 210, which is 322. I can't do anything else on the left side. I can't do anything else on the right side. So let's get our z's together. I'm going to bring the 14z over to the left. It's a positive 14, so I do a minus to get rid of it. Now we have negative 1z plus 24 equals 322. I'm trying to get the z by itself. Next step would be to subtract 24. Negative 1z equals 298. And divide by negative 1. Z equals negative 298. Here's another equation containing fractions. And instead of just having a single number on the bottom, these fractions have actually a binomial, two terms, x plus 1. So that's the only denominator I see. That means that is the common denominator. And let's go ahead and put this 2 over 1 so we can not forget about it when we're multiplying. So I multiply every single term by x plus 1. Then, looking at every term separately, the first term, 2x minus 3 over x plus 1, the x plus 1's will cancel. And I'm left with 2x minus 3 equals. Then for the next one, we'll simply distribute the 2 times the parentheses. 2x plus 2 minus. Now, anytime I see a minus in front of a fraction, especially, I have to think about the fact that that minus affects both the 3x and the negative 1. The minus distributes to both of those. So after I cancel out my x plus 1's, just to help me keep my signs straight, I'm going to put the 3x minus 1 in parentheses. This is something I always do when there's a minus in front of a fraction. That helps me remember that the minus affects both the 3x and the negative 1. So let's go through now and do that distribution. We've got 2x minus 3 equals 2x plus 2, and then distributing the negative will make us have minus 3x plus 1. So a minus in front of a fraction, be really careful. On the left side, there's nothing we can do. On the right side, I can combine, let me go ahead and rewrite the left side. On the right side, I can combine the 2x and the minus 3x, which would give me minus 1x. And then a positive 2 and a positive 1 is a positive 3. I can't do anything else on the left side. I can't do anything else on the right side. So let's go ahead and get the x's together. I'm going to add 1x. So we have 3x minus 3 equals 3. Add the 3. 3x equals 6. and divide. X equals 2. This next problem is written a little bit differently. We're given two equations, one labeled y1, which equals 7 times 3x minus 2 plus 5, and then y2, which equals 6 times 2x minus 1 plus 24. Then we're told that y1 equals y2, and to solve for x. So if y1 equals y2, that means I can take the entire first equation and set it equal to the entire second equation. So let's do that. We would have 7 times 3x minus 2 plus 5 equals 6 times 2x minus 1 plus 24. So the y1 equation equals the y2 equation. Now we need to distribute. The 7 times everything in parentheses gives us 21x minus 14 plus 5 equals, then the 6 times everything in parentheses, 12x minus 6 plus 24. On the left side, I can combine negative 14 plus 5, which would be negative 9. On the right side, I can combine negative 6 plus 24, which is 18. Now let's get our x's together. I can move my 12x over. It's a positive 12x, so the opposite is minus 12x. (21 minus 12 is 9. X minus 9 equals 18. And then add 9. 9x equals, that would be 27, and divide. X equals 3. This is another problem that's written a little bit differently. They give us y equals and then a big equation, and we're also told that y equals 0. So what we can do is set the big equation equal to 0. We'll just replace the 0, replace the y at the beginning with 0. So 0 equals 2 bracket 3x minus parentheses 4x minus 6 parentheses bracket minus 5 parentheses x minus 6. Okay, we've got a lot of parentheses here, and what I would do first is that whenever there's a minus in front of a parentheses, I always fill in a 1 and think of there being a negative 1 there. And then that helps me remember to take that minus and distribute it. So we have 0 equals 2 bracket 3x, then distributing the negative 1, minus 4x plus 6, and close. And I can take the negative 5 and distribute. Make sure you include the negative. Negative 5x plus 30. Now within the bracket, I can combine 3x minus 4x. 0 equals 2, and I don't have to keep doing the bracket. I can do parentheses, it doesn't matter. 3x minus 4x is negative 1x plus 6 minus 5x plus 30. Then we need to distribute the 2. 0 equals negative 2x plus 12 minus 5x plus 30. Now let's combine like terms. Everything on the right side we'll look at to see if we have any like terms. I've got a negative 2x and a negative 5x, which is negative 7x. I've got a plus 12 and a plus 30, which would be a positive 42. Okay, we're trying to get the x by itself. Let's move the 42 over. Negative 42 equals negative 7x. And divide. Make sure you keep the negative with that 7. And x equals 6. On all equations, you can always take the answer and plug it back into the original problem for x and make sure it makes the original problem true. You can always check equations.